Okay, in this video I'm going to show you some examples of factoring a quadratic trinomial when the leading coefficient is 1. Okay, so remember quadratic means that the degree is 2, the degree of the polynomial is 2. Trinomial means we have 3 terms, and the leading coefficient of 1 means the coefficient of the highest power is 1. All right, we're going to do a couple of examples to warm up. Okay, here we're going to multiply the binomial x plus 3 by the binomial x plus 2. So we do the first terms first, so we get x squared. Then we multiply the last terms, so plus 2 times x. Then we do the inside terms, so plus 3x. And then the last terms, so plus 3 times 2, or plus 6. So this ends up being x squared plus 5x plus 6. Okay, let's do one more warm-up and we'll look for a pattern. Okay, again, we multiply the first term of each, so we get x squared. Then the outside, so plus 4x. The inside, plus 7x. And the last, plus 28. So this ends up being x squared plus 11x plus 28. All right, so now let's start talking about factoring. So factoring, which is actually useful in a lot of instances, for example, if we have a quadratic equation that we need to solve, when we're factoring, we're going from the trinomial as it is multiplied out. So we're given it in multiplied out form, and we're asked to find the 2 binomials who are the factors of it. So the 2 binomials such that when we multiply them, we get the trinomial. So what we're going to do is we're going to look for a pattern here. So you see this 5x. This came from adding the 2x and the 3x. So where did the 2 and the 3 come from? The 2 came from here, and the 3 came from here. So now let's look at this number 6 here, which came from here, which was the last one. So this number 6 here came from multiplying the 3 by the 2. Okay, so again, the 5x came from the 2x plus the 3x, and the 6 came from the 3 times the 2. All right, let's look at this warm-up here. So this 11x came from 4x plus 7x. Well, where did 4x come from? 4x was x times this 4. Where did the 7x come from? It was 7 times this x. Okay, so this middle coefficient here, the 11, was coming from the 4 and the 7. Okay, so we added those. All right, well, where did this 28 come from? This 28 came from 7 times 4. Okay, so once again, this 11 is equal to 7 plus 4. This 28 is 7 times 4. So that is the key pattern for factoring trinomials when the leading coefficient is 1. Okay, so when I have the quadratic x squared plus b times x plus c, the number b here, okay, so the coefficient of x is going to be the sum of the last 2 terms, and this number c here is going to be the product of the last 2 terms. Okay, so that's our pattern. Okay, let's factor this quadratic here. So we're going to have 2 binomials multiplied together, and we're going to have an x and an x, so that when we do the first 2 terms multiplied together, we get that x squared. And now these last 2 numbers we're going to get from using our pattern. So the sum of these has to be 10, and the product of these has to be 21. Okay, so we're looking for 2 numbers whose sum is 10 and whose product is 21. Well, let's take 5 and 5. Well, these are 2 numbers whose sum is 10, but the product is not 21. So the 2 numbers are not going to be 5 and 5. Let's do 2 and 8. Okay, so the sum of these 2 numbers is 10, but the product of these 2 numbers is 16, which is not 21. So we try again. Okay, and so, after you get enough practice, you don't have to try too many times. Let's see, 3 and 7. All right, these two numbers have a product of 10. I'm sorry, these two numbers have a sum of 10, and they also have a product of 21. So these are the two numbers. They're going to fill these slots. So we're going to have plus 3 and plus 7. Okay, so this x squared plus 10x plus 21 is equal to x plus 3 times x plus 7. And it's really easy to check if you're correct. You just FOIL it out. Okay, so to check, we have x times x, which is x squared, plus 7x, plus 3x, plus 21. And so that is, in fact, equal to x squared plus 10x plus 21. Okay, I'm going to write a couple of examples for you to try, and why don't you pause while you work on them. Okay, here are the two examples. Okay, again, in the first case, we're going to have x and x as our first terms, so that we have x times x, which is equal to x squared as the first term in our quadratic here. All right, these two numbers need to have a sum of 7 and a product of 12. So those two numbers would be 4 and 3, because 4 plus 3 is 7, 4 times 3 is 12. So one of these will be plus 3, one of these will be plus 4. So that means x plus 3 times x plus 4 is what x squared plus 7x plus 12 is in factored form. Okay, so here we have a sum of 5 and a product of 4. The two numbers that satisfy this are 1 and 4. This means that x squared plus 5x plus 4 factors as x plus 1 times x plus 4. And because each of these is x plus a number, it doesn't matter which one we put the plus 1 in and which one we put the plus 4 in. And I encourage you to always check your answer. So here, if we were to FOIL it, we get x squared plus 4x plus x, so that's plus 5x, plus 1 times 4, which is 4. All right, so in these examples, I've given you all the terms have been positive. Well, suppose we have a negative term thrown in there. We're still going to go through the same procedure. Okay, so again, anytime our leading coefficient is 1, the two terms are going to start with an x. Okay, so this is the easiest case of factoring. All right, in this case, the negative 4, that's what the sum is. Okay, so the sum is always the coefficient of x when we have a leading coefficient of 1. And so the sum is negative 4. Negative 12 is our product. Okay, so we need two numbers whose sum is negative 4 and whose product is negative 12. So I know that one of the numbers has to be negative and one of the numbers has to be positive. Well, let's start with the product one in this case. Well, 6 and negative 2. These are two numbers whose product is negative 12. But if I add them, I get positive 4, not negative 4. However, if I take negative 6 and positive 2, my product is still negative 12, and my sum is negative 4, because negative 6 plus 2 is 4. This means that x squared minus 4x minus 12 factors as x minus 6, x plus 2. Okay, I'm going to give you two to try on your own. Okay, why don't you press pause while you try these two. All right, in this first one, the two numbers we're looking for have a sum of 3 and a product of negative 18. So the numbers that work out for that are positive 6 and negative 3. So that means that this factors as x plus 6, x minus 3. All right, in this case, we're going to have a sum of negative 6 and a product of 8. So since the product is positive and the sum is negative, I know that both numbers have to be negative. So the two numbers in this case will be -4 and -2. So -4 times -2 is +8, and -4 plus -2 is -6. So this will equal x minus 4, x minus 2. Okay, so there's a lot of guess and check that goes into factoring. So as long as you can multiply and add, you eventually will be able to factor the ones that are factorable over rational numbers or integers. We'll just deal with integers right now.